So for our Trig pre-calc semester review, like we kind of talked about in class, I will do every single problem. Every single problem will be on here, but you can review however you want. If you want to go skip around to find some problems that you are more concerned with than others, that's fine. If you just want to listen from beginning to end and work along with me, writing stuff on your unit circle page, pausing and writing this down or trying to do it by yourself, that is just fine. And so as we kind of go along, I'll give you some tips and maybe things that, oh yeah, this would be something good to write down if you don't remember, different things like that. So we're going to start at the beginning. The review does go like our semester. It goes chapter 1, chapter 4. So chapter 1 is all of the review, algebra stuff. Chapter 4, all of our trig. Chapter 5, which has a little bit of identity, still some trig stuff. And then chapter 6, triangles, all of it. And it goes in that order. So if you want to go hunt for those law of sine, law of cosine problems, they're at the back. If you want to do the early stuff first, you can do that. That would be, at the beginning if you want to do chapter 1 stuff. That's where I'm going to start. So number 1 says, write the slope-intercept form of an equation of the line described. So slope-intercept form we know is y equals mx plus b. It's the easiest one that we can find. And we are given a point, and it says that it's also parallel to y equals negative 1/5 x minus 4. So out of this piece here, parallel we know that means the same slope. So whatever our new line is going to be, it's going to have the exact same slope. That's what we have. And so when we're given a slope, we know it's slope, and we have an x value, and we have a y value. If we have a point and a slope, we're going to use point-slope form to write our new equation. So point-slope form, this is maybe something that we feel like we need to write down because maybe we forget it just a little bit. So we get y equals m times x minus your x point plus y. So when we put all these pieces of information here, we just got to simplify. I know that I have negative 1/5 x minus my x point, plus your y value, so plus a negative 3 would be a minus 3. And if we distribute to simplify, looks like we're going to get y equals negative 1/5 x, which is what we wanted. We said it was parallel. We would need the same slope. Negative 1/5 times a negative 5, that's pretty convenient. That multiplies out to a positive 1. Minus 3, so we just simplify this to get slope-intercept. We get y equals negative 1/5 x, plus 2, minus 2. And we have our slope-intercept form. We did this really, really early, but if you have a point and a slope, we take point-slope, and we go to y-intercept, or slope-intercept. That's what we're going to have to do. And so maybe this comes in handy. Maybe this is something to write down. Who knows? It's up to you. Number 2, this one's going to be a piece of cake. I didn't even write all the answer choices on it. Which set of ordered pairs represents a function from P to Q? And they give you all these things. Basically is from P to Q, these are your X values, and these are your Y values. That's how they're going to match them all up. So we have all of these points, these sets of ordered pairs that are left. But which one represents a function? You guys always tell me that a function has to pass the vertical line test. That is true. But when that happens, we know that x's can't repeat to be a function. That is a no-no. They cannot repeat 1x for all the y's. 1x and 1y. The x values can't repeat. So like if we look at A, looks like my x values go 1, 2, 2. Oh, can't choose that one because the 2 gets repeated. B, they're all 3. Can't pick B. C, it goes 1, 3, 1, 3. Can't do that one. So it looks like D, where we have 2, 0, 3, 2, and 4, 0. I don't care that the y values repeat. That's not a big deal. But 2, 3, and 4, they are all different. So I'm going to go with letter D as my answer choice because the x values do not repeat. Keeping along with functions, we got our function notation, and it's f of x. And we see this a lot. We saw it with trig functions, all this stuff. Basically, f of x is a fancy y. We're just not going to panic about it. The only reason that x is in parentheses is because anytime it's not an x, it tells us what we need to plug in. So this is like 2 problems in one. I actually have to plug in 2 different things. The first time, I'm going to, instead of seeing an x, and I know this says x and then there's p's, really this should say f of p, and then wherever you see a p goes everything else. Okay, so we can do that. So the first time, if I see f of 0, that means that wherever there was a letter, now goes a 0. So it's not 3 times p squared, it's 3 times 0 squared minus 4 over 0 squared. And then the other one says f of negative 3. And we're going to be very careful that we put the negative 3 in parentheses when we do this, or you will get the wrong answer, and Ms. Glasser will not be happy. So let's see. The top one, this is pretty easy. You have a 0 squared on bottom. You cannot have anything on bottom. The top is undefined. That does not work. You cannot have a 0 in the denominator. So f of 0 is undefined. You can't do it. You can't plug in a 0. It does not work. The top part you can. So let's see here. If we simplify this, negative 3 times negative 3, that's a positive 9. I'm not going to multiply the 3 times negative 3 first. Only the negative 3 gets squared. You guys know that. And on the bottom I get another 9. So let's see here. 3 times 9, 27 minus 4. Not times 4, minus 4. So it looks like I get 23 over 9. That does not simplify, so we're going to leave it as 23 over 9. If it was since your final is going to be multiple choice, if you see all these decimals, try to type it in as a decimal, see what it is. I could probably guess, though, if like problems like this, it's going to leave it in a fraction. So anytime, all function notation is anytime you have something else besides a letter inside the parentheses, you plug it in. So remember, in class I did the silly f of smiley face or f of heart, and we could plug it in. Whatever it is inside, we plug in that. That's what we're going to do. Also, in early chapters, we talked about domain and range. And what we're going to do on this one, on number 4, is we're going to find the domain of the function. And we know that domain are x values. So basically what this question is saying is what x's are not allowed. That's what we're trying to figure out, that there's probably some x that's not allowed. And the reason why I know that is because I have a fraction. If this looks something like y equals x squared plus 2, well, big whoop, I can plug in any x. I could plug in negatives, fractions, zeros, positives, and I'm always going to get a number because I don't have a fraction. I don't have anything that's going to be undefined. I don't have square roots. You know, we can't have negative numbers under square roots. I'm always going to get a number. But because I have a fraction, I know something could go wrong because I know the denominator is a problem. That what we don't want to happen is I really, really, really don't want this denominator to be 0. I can't let it be 0. And so if I can figure out what number is going to make that 0, that's the number that cannot be in my domain. That's the x that is not allowed. So let's see here. If I was going to solve this, we're going to add 6 to both sides. So x cannot be 6. And we can see that. If I plugged in a 6 right here, I'm going to get 0 in the bottom and I get a problem. So I don't want to do that. We're going to take that out. So we're going to say I can choose everything else except 6. Everything else except 6. And so if we look at our answer choices, I see one that looks like this. Negative infinity until the 6, and then 6 up to negative infinity. And because these are parentheses, it's leaving out the 6. It's saying everything up until the 6, but you can't actually pick the 6. Picking the 6 would be the square bracket. Remember we talked about that? But since we're not, since it just gives us parentheses, I know it's saying everything except the 6. Negative 6 is fine. B, it says from negative infinity to positive infinity. I know that's not okay. D is too small. D constricts it too much. I could pick a lot of numbers. The only thing I can't pick is that 6. That 6 needs to be left out. So this is what option A. That's what we need to choose. Another thing we talked a lot about was transformations. And we first did it with parabolas, square roots, cubics, absolute values. We did a lot with those. And then we changed it to trig functions. So we're going to talk about the transformations. Transformations, this is usually something like up, down, left or right, flipped. Those are the things that we're going to look for. And so it says, use the parent graph f of x's square root to determine the transformations that occur in g of x. This is what it started with. But I know that 3 things have happened because this has been added, this -5 has been added, and this +3 has been added. And so we need to state every single thing that has occurred with this new function. One thing we do know, negatives in front, this has been flipped or reflected, whichever way you want to write it, reflect it, over the x-axis. It has turned upside down. It took it and flipped it. It went from being the square root to being square root. Turn it upside down. So we're looked at. This number tacked on to the end is an up-down movement. This has moved up 3 spots. So now I've sent it up. Every single point is up 3. And inside is always opposite of what we think. It's always a left-right movement, and it's opposite of what you think. So it looks like I went -5, so that would be to the left 5. But I really went positive. I went to the right 5. So I have flipped over the x-axis. I have gone right 5, and I moved up 3. So maybe you can write numbers on the end go up, down. Numbers inside are opposite, and they're left, right. Numbers on the outside, they get flipped up and down, or if it's negative, it gets flipped over. If there was a 2 in front, we would call that a vertical stretch. Remember, because we pulled it up, it's kind of like an amplitude change. I change the amplitude, I make it stretch it up, stretch it down. Those are the things that we could write on your unit circle page if you needed any extra tips. 6 I took a picture of, and I wrote a few things on it, so maybe this kind of helps us out. And we have this crazy picture, and it says, determine the intervals where my function is increasing, decreasing, and constant. And the thing about this function, we know you're going to get silly, weird, crazy functions, is that it has a gap in the middle. There's nothing in the middle. So I don't have to write an interval for anything that happens because something stops. And when we're talking about increasing, decreasing, and constant, I want this on someone's unit circle page, preferably every single person that is taking Trig Pre-Calc. We are talking about x values. We read everything left to right. So we need to be talking about x values. I do not care about y values. I know that x values, I'm coming from here all the way to here, and then it stops, something happens. That interval would be -infinity to -2. And then it stops. There's nothing, there's nothing, there's nothing. I pick up here from 2, and I go out forever and forever and forever to infinity. Those are my x values. I know this line goes down. I don't care about y values. I'm going x direction. I'm going as far right and as far left as we possibly do. We read everything left to right. And so we need to decide, okay, what is happening with these? Well, if I come left to right, this line is traveling up and up and up until this little spot right here. Well, that means that line is increasing. I'm going up and 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 stop, and it stops. And then there's a gap, and then there's nothing. And then from 2 to infinity, then the line says, well, we're going to turn around and head south. Now we're tired of increasing, we're going to decrease now. And so it has decreased, not 2 to -infinity, 2 to +infinity, because I'm talking about x values. You got to think, your mind has to think differently. Yes, the line is going down. It is decreasing on the x intervals, because I'm going left to right. That's where it's going to increase from. So this looks like it's decreasing from 2 to infinity, increasing from -infinity to -2. That's going to be option C. Be very, very careful because C is very, very close to B. B, they just switched their words increasing and decreasing, so be very, very careful. Again, number 7, I just wrote in the stuff in on my picture. I'm talking about x values, so I know something happens here, something happens here. Excuse me. And the x values, my x intervals, this looks like something happens from -infinity until that -5, and then kind of stays kind of boring from -5 to 2, and then from 2 on out, remember we're reading left to right always, 2 on out to +infinity, going to do something else. Those are my intervals. Write the intervals first, then write the letters over the top that go with it. The middle one's easy. That's constant. Nothing happens in there. It's a straight line. That line is a straight line. That is a constant function. So let's see, it's constant on -5 to +2. Well, looky there. Every single one of our answer choices has that. We got to choose something different. Got to choose another piece to help us out. It looks like this piece, it's going to head up. So it's going to be increasing on this second interval. So increasing from 2 to +infinity. If we just took it right there, that means we're going to have option C again. But we can fill in the last piece. This one is heading down. As I go left to right, this graph heads down. It is decreasing. So I decrease, I remain constant, and then I increase. This would be option C. Again, be very, very careful. B and C look so close, but they are different. A and D look really close, but the problem, they chose Y values. We don't care about Y values. It is always and forever X values on increasing, decreasing, and constant. All right, I'm going to do these two out of order. I'm going to do number 9 first. Number 9 gives you two equations and then says find G plus F of X. And so we know that when we see something like this, this means, hey, take G of X and add everything in F of X to it. Got it. So I'm going to take G of X. I'm going to add everything in F of X to that. And so, sometimes we think, well, how do I do that? If I'm just adding everything to it, you can say, oh, distribute the positive. Basically, just drop the parentheses. Adding means drop the parentheses, plus the 4x, plus the 1. I'm adding everything. Nothing changes. You don't need to distribute a positive. You just need to add everything together. I add this, I add this. We're going to combine like terms. It looks like nothing combines with that -x squared. So that one's done. I only have one thing with an x, so I have plus 4x. However, I do have, did I write something wrong? Oh, that was supposed to be, let me fix it. This was supposed to be a -1. So -1 here, -1. That was from I just wrote that wrong to begin with. So -1, -1. It looks like I do have +2, -1. So when I add them together, +2, -1, I get a +1. So that's my final answer. Anytime you see crazy notation that looks like this, just think about, okay, what sign is that? What operation is that? That said add, find the sum, add them together, add them up, combine like terms. The difference, number 8, you have a subtraction sign. So I'm going to take everything in F and subtract everything in G. This is where it does matter because it's not just minus the -3 or x cubed. It is also minus the -4x. So I get -3x minus 5 plus x cubed now plus 4x. All the signs on the second piece change because it doesn't matter with plus signs. It matters with subtraction signs. So let's combine like terms. It looks like I get x cubed plus x minus 5. Plus x is 4x minus 3. So I get my final answer. So we look at the operations. You could have multiply. That would be a dot. You could have divide. The other one we talked about is composition. Could I compose them together? It looks like fog or it looks like goff. It's an open circle. And this is really written F of G of X. So the thing I'm plugging in now, I'm going to take every single thing that is in G and I am plugging it in for A. We talked about whatever's inside the parentheses gets plugged in. Okay, so what was inside the parentheses is no longer a squared minus 1. Now it's 2a plus 4 squared minus 1. And so we know that if I see this little piece right here, I'm not going to distribute that square. You can't do that. I will slap your hand for that if you try it. Don't do it. We're going to FOIL. So we're going to write it out twice, and it looks like we get 4a squared, 4a squared plus 8a plus another 8a, so plus 16a. 4 times 4 plus 16, and that minus 1 that was originally there. We had an original minus 1. And we're combining just like terms, so these two are the only like terms that we have. So 4a squared plus 16a plus 15. So let's try another one. Maybe pause it this time. I'm going to just work it silently. So see if you can figure out how you would do this composition. This one, f, is the inside function. This chunk, do a different color, this piece has to get plugged in for that x right there. Okay, so I'm going to work it silently. So maybe don't look up, maybe see if you can do it yourself and see if we get the same thing. Alright, this one should be easier. No foiling. It's not foiling this time, it's just distributing a 4. Instead of 4x plus 3, it's 4 times 4x plus 2 plus 3. So we should get 16x plus 11. Alright, 12 and 13 definitely have something you're going to want to write on your unit circle. We're going to find an inverse. Find an inverse. There were 2 rules. Always and forever. The first rule, switch x and y. You may remember the last rule now. Switch x and y. Rule 2, solve for y. Always, always, always. Switch x and y and solve for y. I know you have f of x and g of x. Those are fancy y. So if you want to, alright, change it. It's not going to be a big deal. So we get swap x and y. Literally, I'm changing their spots. This becomes the x. This one becomes the y. And I got to get y by itself. The first thing I'm going to do is add that 5/3 to the other side. Move it over. Okay, I could divide by 1/3. We could divide by 1/3, but dividing by a fraction is really like multiplying by its reciprocal. And so I'm going to do that instead, because now I have a 3 on top, 3 on bottom. Those all go away. I have y. And it's 3 times each piece. So 3x plus, well, looky there, a 3 on top and a 3 on bottom, just 5. And so my inverse, you may see it as just y, you may see it as y with a little -1. It's just a notation, but would be 3x plus 5. Okay, on 13, don't let it scare you just because it has a cube root. We know how to undo all of this stuff. So the first thing, if you want to throw in a y, that's great. I'm going to switch x and y. I got to switch them. Alright, and to get the y by itself, I have to undo this cube root. And we know that squares undo square roots undo squares. So to undo a cube root, I need to cube both sides. Now I get x cubed equals, this whole root is gone, -y plus 2. And let's see here. I don't really want to deal with the -y, so I'm going to cheat and move the y over so I get a positive y. And then move the x back over. So I get -x cubed plus 2. This one goes perfectly along with C. They just wrote it this way. They wrote 2 minus -x cubed. It's the same thing. So let's see, 13 is C, and 12 should be B, if we match all of the answers up to which ones they're supposed to be. So definitely inverses. Switch x and y, solve for y. That is something I would be doing. You know how to solve for y. You know how to undo everything. But the rules, sometimes we forget, oh yeah, that's what I'm supposed to do. Alright, now if you flip to that next page, this is where the bombardment of trig problems come in. They look like a lot. The work is very small. Very, very small. 14 through 16. Use the unit circle to determine the exact value of theta in degrees. This is saying there is some angle or angles where tangent, where y over x equals square root of 3 over 3. Or negative square root of 3 over 3. I think I wrote that one wrong again, so let me put in my negative. Negative square root of 3 over 3. Okay, all we have to do is go hunt around our unit circle to find something that's going to give us a y over x is going to be a negative square root of 3 over 3. I'm going to help you out. Don't pick quadrant 1. Don't pick quadrant 3. Why? Because these are double positives. These are double negatives. I'm going to have a negative over a negative. I don't want that. I want this number to show up to be a negative number. So it's going to have to be in quadrant 2 or quadrant 3. So let's see here. If I go to quadrant 2, let's try one. Let's try 150 degrees. If I try 150 degrees and its y value should be 1/2, its x value is negative square root of 3 over 2. The denominators are going to cancel out. They're going to divide out. So I'm left with 1 over negative square root of 3, and we can't have square roots in the bottom, so we move it to the top. Well, looky there. What do you know? 150 really does work. And we're going to see if there's another one. I'm going to go, good place to check straight across. If I check straight across at 330, it's usually a good place to check. You can check everywhere else. The 120 is not going to work. The what is that one? 310? 300, sorry. The 300 is not going to work. So the y over x that's going to give us what we want happens at 150 and 330. We check our unit circle, and once you find one, always see if the one across from it works. See if that one works. Either the one across from it or the one straight above or below. Those usually help. These other two are a piece of cake, though. Cosine and sine. I know in my unit circle that cosine is x and sine is y. So I'm looking for where in the world is an x value. Just an x value by itself, a negative 1. There is one spot and one spot only, and that is 180 degrees. It is the only spot that has an x as negative 1. It's the only thing. It's my only answer. Sine, where it would be a positive square root of 3 over 2. That happens in 2 spots. If I'm looking around, I know that it can't be down here because all of these y's are negative. It has to be positive, so not quadrant 3 or 4. But it could happen at 60 degrees, and it could happen straight across from it, looky there, at 120 degrees. Then I get 2 values where the y value is positive square root of 3 over 2. Remember, your unit circle is already there. And on our paper somewhere, we probably have that tangent is y over x, sine is y, cosine is x. It really is just knowing how to use your unit circle and using the coordinates to find this x value or this y over x. Or if it was cotangent, not y over x, but x over y. If it was secant, not x, but 1 over x. All the different things that we could find. We could take the reciprocals. We could do that. Just knowing how we use our unit circle. Alrighty, and our last 2 problems of this video are going to be which quadrant do these angles end up in? Let's do the degrees ones first. We seem to be more comfortable with degrees. This is a huge angle, much bigger than 360, and we're going to figure out just how much bigger than 360 does this angle go. So if I do 564 minus 360, then I get 204. So that means this angle has not only gone 360 degrees, but has gone 90, 180, 204 more degrees. Not quite an extra 270. So it's going to fall back within quadrant 3, or we could do Roman numeral 3. That's where it's going to end up. When we get to the radians ones, don't panic. Forget about the pi for a second. If I do negative 5 over 12 on my calculator, I get negative 0.42. So it's not quite negative 1/2. I know where half of a pi is. Positive 1/2 pi, pi over 2 is up here. So that means that negative 1/2 pi is below. And it's not quite there. It's a tad bit smaller. So that means it doesn't quite get all the way to negative 1/2 of a pi. It stops short. It stops short of 1/2 of a pi. It falls within quadrant 4. So that one. So if you get something that is a radian and it has a crazy fraction on it, figure out what the decimal is. I knew this one says, well, it's almost a half or negative 1/2 of a pi. It almost goes all the way down 90 degrees, but it stops short. It's not quite there. And so I can say that's where I'm going to look at. I'm going to follow what I know where negative 1/2 a pi is, and I know it's going to stop short of that. I'm going to use the decimals instead of the crazy fractions to help us out. So maybe that's a little tip right on your unit circle, but quadrants usually we're pretty good at where these end up.